if you really need it, but basically I'm a developer with 18 years in architecture, and actually the second job that I got was I was given the task of designing a large, and I'm talking about 3 years almost, system for a company, and who gives that shit to a third-year student? Like I can't imagine right now, like, who thought that was a good idea? But anyway, they did. So I had to learn how to design systems very, very fast. And then I made a lot of mistakes. Actually, I made most of the mistakes. And so after years, I can talk about them, right? So I work for a company, which is Bottega, it minds. And what we do is, apart from just normal coding with teams, we got clients, we do consulting, we do stuff like, reviewing of the architecture and so on, designing new systems or helping design the systems. I also give workshops. And it turns out that there is a lot of, well, most of the errors that I've made, well, I see that people are making them over and over again. And that it doesn't matter whether these are just junior developers or these are architects with 30 years of experience. They are the common mistakes, I would say. So this is the talk about that, right? Now, excuse me if I'm going to be a little bit slow. I'm usually a very fast talker, but first of all, I got the feedback at the last conference for developers this week that I'm talking too fast. And second, it's Friday evening and I'm exhausted, right? I just had 3-day workshops on architecture and I'm exhausted. All right. So one thing, what I'm going to talk about, sorry for those sounds, let me close this. Okay, what I'm going to talk about might not apply in your context. What I do is I usually do enterprise class applications in Java or on the JVM, because they are usually in 3 different languages or in all 3 languages like Kotlin, Groovy, and Java. But my context doesn't work, and my problems do not work in game dev, they do not work in robotics, in high-frequency trading, and they might not work in your shitty organization that makes you cry, for example, right? Because quite often what I see when I teach the architecture and when I'm trying to help somebody design the system is that they say, like, yeah, that's completely fine and completely fair, and it makes sense, except it won't work for us because we are not allowed to, for example, do something, right? Or we have to use the Oracle database, which we cannot modify, or something as stupid as that. So basically, I'm not responsible for that. Take this, all my suggestions, take with a grain of salt. It might be completely wrong in your context, and even if you do the same kind of applications that I do, but something's different about the organization or anything like that. So just don't take my word as as given. Basically, take it with a grain of salt, at least. And the second thing is, well, we're going to talk about the architecture and the mistakes, but there are actually several types of architecture, right? There is this enterprise class of architecture when we are talking about changing the company in terms of actually how do we set it all up, right? How do we organize the people, the departments, everything like that. We're not going to talk about this. Now, this is important, and most likely this is the most important part, because if you get that wrong, then the software architecture will always follow the organization due to Conway's law. But it's a nice thing, but a little bit problematic. I'm not going to talk about that at all. The next thing we are not going to talk about is the infrastructure architecture, right? So if your job is about service meshes, Kubernetes, event buses, and keeping all that stuff alive, I'm not going to talk about that at all, right? These are different kind of problems. And while the software architecture that I'm going to talk about depends on the infrastructure, and definitely the infrastructure impacts the software architecture a lot, like what kind of a message bus do you have? If you don't have a message bus, that's going to change my approach to the architecture a lot. If you have Kafka or Pulsar or maybe anything that can store the events forever, that's going to change a lot. But in this talk, we are not going to focus on the infrastructure. We are going to talk about the mistakes on the software or the logical, let's say, level, right? So what we are going to talk, and my problems that I'm going to talk about are usually about modules, microservices, and basically everything that the normal developer that creates business features have to deal with, okay? All right, so here's the first problem. First of all, the problem is that while everyone knows what their features are, people usually don't think in terms that there is no such a thing as a best architecture. It's only about the architecture which is optimized for some specific quality. And I'm talking about non-functional qualities, right? If you want to have, if you ask developers about what are you optimizing your architecture for, they either cannot answer or they give you an answer like something like maybe performance. Yeah, my application has got to be very performant. And then you ask them, how many requests per second are you going to handle, or transactions per second, right? And they give you a number, 4,000. And then you say, 4,000? That's 20 years ago, I could do that in a PHP on a single server. Like, what are we talking about, right? So if you think about it, what happens is that people do not actually understand what they should optimize their microservices for, or their monolithic system, basically their architecture, right? Sometimes they know, like if you do, let's say you are in the market of handling advertisements or basically selling and buying very fast, right? Then you know you got 20 milliseconds. If you are handling some maybe the payment cards, you know you got 2 seconds, stuff like this, right? Most of the developers, they try to produce a scalable solution while they do not optimize what it is. It's really important. So here's my first lesson that I wish I knew when I started. If you don't know what you're going to optimize for, do not optimize for performance. Like, don't do anything stupid and your application will most likely work, right? Most systems will work on a C64 powered by a potato, right? That simple, like seriously, okay? But if you don't know what to optimize for, then please try to optimize your system and your design on 2 things. Maintainability is the first one. What is it? Well, that's how much your people are going to spend to keep the system alive. How do we count this? Very easy. If you already have a system, take a look at how much time does the team spend or developers spend on average on things like bug fixing, or explaining something strange to the business, or basically trying to keep the system alive, right? This is the cost of the maintenance. And this is the most important thing, because when you have low cost of maintenance, right, then it means that you can have several developers working on new features. But if half of your people are working on keeping the system alive, you are only left with half of the people to develop new features. So try to optimize your system on keeping the maintenance cost low. Now, the next thing is extensibility, which is how easy it is to add new features, right? And I'll give you an example. We had a situation when we were working in a monolithic application, basically, and the team estimated a new feature that was requested for, like, we are going to implement this with a single team in about half a year, right? 6 months. And then we actually decided to implement this as a microservice. The guys did it. It turned out it took only 1 month, right? Now you have an answer of how bad the architecture was in terms of actually prohibiting you from going very fast when you develop new things, right? So if you think about it, try to optimize on maintainability first, and the second on how easy it is to extend the features. So basically to add new features to your system, right? Now, if you're in a startup, there is a third thing that is very important, and that's the most common thing that you should optimize for. And that one is flexibility, which is how easy it is to reuse the parts of your system. And that's because, well, when you are in a startup, quite often what you do is a pivot. After every half a year, maybe every 3 months, if you're unlucky, or maybe every year, you will have to do a pivot. Basically, the company is trying to find a marketplace, right? Or its own place in the market. So basically, one day you're developing a system which is like a Heroku, which is like a product of every cloud system. And the next day, what you find out is that nobody wants to buy it, so you focus on your database, which is called MongoDB. Now that's what you sell. This is a very typical situation for a startup. So if you are in a startup, if you don't have a stable business yet, then think in terms of, okay, I'm going to create this architecture so that I can reuse different parts of it later on. And I can change my direction and do something completely different, very easy and very fast, because I already have several tools there, right? Okay, so be sure that you know what you optimize for and make a conscious decision about that. And these are the three I would suggest, unless you actually know that you have to optimize, for example, for security, because you'll be attacked because, well, you are doing like, let's say, a Bitcoin market, right? So it's obvious you're going to get attacked, right? Okay. Now, knowing this, when we know what we optimize our architecture for, there are only 3 types of the architecture right now, which are quite common, or maybe 4 of them, right? Let's talk about them a little bit. There is the modular monolith, which is single apps with modules. Not too many people know how to do a module. There is the distributed synchronous system, which is usually microservices talking through REST, right? And that's only if you have the independent deployment of each microservice. If you have several microservices and you have to deploy them together, or you have to synchronize the deployment, who goes first, then what you have is not a distributed synchronous system, but a distributed monolithic system. And that's an anti pattern, right? And a third kind of a system, which is event-based distributed system, right? Which is microservices talking through a message bus or basic queue, right? Now there's a fourth kind of a system, which is Lambda, but I'm not going to go into that because it's usually not worth it in terms of if you have a stable system, it costs a lot more, right? But it's faster to start. But let's forget about it for a moment. Now these are the 3 most common. Now there is a lot of things about which one has got like what kind of benefits and so on, but not too many people talk about the problems. So let's look at this from the perspective of problems. What are the problems with this kind of a system? And then I'll let you decide which one you want, right? Or which one you need. When you have a modular monolith problem, the first problem is that there is a big risk of deployment. What does it mean? Well, what happens is that if you have 200 people working on a monolithic system and then you got a beautiful architecture, beautiful modules, wherever you are trying to deploy the application, because you just make that small little fix, like a typo, for example, in the UI, you have to deploy the whole application from the master, right? So what happens is you're going to deploy all the commits which happened from the last deployment. Even if you have, deploy every day, that's going to be like maybe 100 commits because you got 200 people working on it, right? Now, what can break in that scenario, that situation? Everything. Basically, you are deploying a big unknown thing. You are not aware of what you are deploying, to be honest, right? So it can break. And when it breaks, it can kill your whole system. Because, for example, if you have a memory leak in a single monolithic application, the whole application is going to say bye-bye. So the first problem is this is a big risk of deployment in a monolithic system. If you cannot handle, if your business cannot handle this big risk of deployment, don't do modular monolithic systems. Don't do monoliths at all. Go into microservices, okay? Now, the second problem is that to have any kind of equality in monolithic system, you have to have a lot of self-discipline between all the developers, right? And when we're working in a single team, I have like 7 people, let's say, then we can work out the common way to approach problems. And basically we agree, how do we do this? Are we using functional programming, object-oriented programming, a mix of both? Are we going to follow the clean code? Are we going to do something completely else? Like, well, how do we do this stuff, right? Cool. Now, we learn from each other so that whenever we are rising our levels, we are spreading this across the whole team. But that doesn't happen when you have 100 people. When you have 100 people working on a single code base, what happens is, well, you never agree with each other, right? So these people are making basic mistakes, right? And you can't teach them because you don't have time. And these guys are trying to push Scala everywhere, right? So what's the point? And basically, and so on and so on. So it's really hard to keep the system in a good shape in such a situation. And to be honest, it's usually not worth it. These days, when I have the team, if I had 10 people, I can build a modular monolithic system. If I had 20 people, and these were like Tomek Nurkiewicz type of people, like the top of the top, right, the best of the best, I could create a monolithic system, modular monolithic system, right? But if I had just the average developers that are here on the market, no way. With 20 developers, I'm going to build a microservice-based system, or basically a distributed system. Doesn't have to be like a lot of microservices, could be just a little bit distributed, like 5 applications perhaps. This is okay. But I won't be building a monolithic system because we'll waste way too much time on trying to agree with each other and sharing the practices. We should share the practices, but it's impossible with 100, right? Okay, then there's another thing, which is this requires a lot of effort on communication, on communicating the architecture, right? Why? Well, a new guy is joining the team. We got a team of 100 people, or basically we got 10 teams, 10 people each working on a monolithic system. And a new guy joins the system. Nobody introduced that guy to all the rules of the architecture and basically the whole design. And so what that guy would do, they would just, I don't know, maybe connect two different modules that shouldn't be connected, or maybe read from a database of another module, and so on. So they are going to make a lot of mistakes. So you have to spend a huge amount of time on communicating about that. Now, communication is something that the architects actually do, so it should be there anyway. However, if you got microservices, in reality, what happens is that the team is trying to, like, the boundaries are harder to cross, basically, right? You cannot touch my code base because you don't have access to the repository. Maybe you can read it, but you cannot push anything there. You cannot touch my database because you have no access to my database. So I don't give a shit about what kind of a mess are you going to create, because you're going to create that in your own code. So it's easier, right? So we do communicate with microservices a lot, but not as much as with modular monolithic system. It's easier to just go our own ways, okay, and just try to keep the contract fine. Then we have another thing, which in a monolithic system, there is a limited set of technologies. They are already chosen, right? So what happens is that if you want to progress, basically after every 3 years, people are changing their job because they are fed up with the technologies they use. They already know them. They want to learn something new. But in a large monolithic system, it's very hard to actually switch that, right? I still see several systems which work on Java 8, for example, right? And we got, well, Java 16 right now. So basically what happens is that if I want to stay within a company because I want to stay there for several years, I like the culture, I like the money, I like the people, right? I would try to choose the company with microservices so that I can stay there working on the same system. But each time I'm creating a new one, maybe add a new library there, update the data, update the framework, basically add another language. Have a choice in terms of the kind of a technology that I want to use for that single problem. With a monolithic application, I usually can't do that. And if I'm the owner of the company, it's the same situation, because I know that the best people are going to leave after 3 years. And if I want to keep them, I need to give them new tools. Okay, so with microservices, it's much easier. Then the next problem is, and that's the basic problem, you want to create a modular monolithic system, right? Not too many people actually understand what a module is, right? Like, show me the definition. And then if you look into the books, there are not too many definitions out there, right? Okay, so I'll give you my definition of a module. So that this is something that I came up through life, and basically it works for me, and it works very well. So when I'm designing a system, that's what I use, okay? First of all, a module is something with a single responsibility, and that responsibility is being responsible for a process, not data, right? So this module handles registration. This module handles, for example, I don't know, ranking, something else, right? But not a noun, a verb, a process. Okay, then the module has got a vertical slice, actually. So it has got all the layers. It's got its own layer to access the database. It's got a layer for sometimes even the UI layer. It's got all the logic included. It's a vertical slice. If you think in terms of cake, this is not just one slice, the one layer of the cake. This is a slice with all the slices included, right? Now, a module should have a clearly identifiable API and collaborator. So basically, you should know right away where is the access point to that module. And it's very simple. You can do that with, for example, a public class in a package. That's the only public class in the package, so you know exactly which one to touch, right? Now, a module, and that's the most important thing, has got its own database, which means it doesn't mean that you have to set up a new Oracle for this. It means it's got its own tables, and you cannot do any kind of a query, update, insert, whatever, between tables of different modules. If you write your code in a single module, then if you want data from another module, you have to ask the API. You cannot do even a join on different data from different tables. That's the most important thing, right? We know right now that integration through the database is an anti-pattern, and basically this is a horrible mess, and that's why most of the systems look like shit right now, monolithic systems, right? So you have to think in terms a single module, that's my database. I'm encapsulating all of that. I'm not giving away any data. And not only data, the next thing is I'm also not giving up any of my classes. So you cannot touch or basically look at them. And you cannot call any method of any other class except for the API. And it's also very simple to do. You can use packages and the package scope for that. There are other options as well. In Kotlin, you got the open class, not the open classes. You got the internal keyword, right? You can create modules of the build system and so on. But that's the important part. Now, what it allows you to do later on is like when you refactor the whole thing without thinking that somebody's code is going to break because you're changing the classes. No, if you keep the API stable, you can change everything else. Okay. Now, if you use domain-driven design, then a single module is always in a single bounded context. That doesn't mean that a module is a bounded context. Usually what happens is a bounded context has got several modules there, right? A bounded context is a concept where this is a concept from domain-driven design about how we see the world, or how we model from one single perspective the problem that we have at hand. But a module is a concept which has got large technical implications. So you can have several modules in a single bounded context, but you will never have several bounded contexts in a single module. Okay? Now I got to talk about how to actually write this in Java, so I'm going to skip that. But there is a link there in the presentation, and the link to that presentation will also be available at the end of the presentation. Now, that's not how most that's not how most monoliths work. Actually, most monoliths look like this, right? That's very unfortunate, but that's true. And I'm going to open the window again and try to have some air. Okay, so we're not going to talk about the non-modular monolith because it's an anti-pattern. Everybody has got that, right? We're going to talk about distributed synchronous systems. So now we are talking about the REST API and the microservices is based on REST API, right? What are the problems? Because like everybody is going to sell you that. What the problems are. First of all, you need to model everything with eventual consistency, right? And there's no way around that. So whenever you're making a call inside the JVM, that's simple. It takes just a few milliseconds, maybe less. The problem is that within the microservice system, that is going to take tens and hundreds of milliseconds because you have to take the speed of light into account. The next thing is that whenever you do microservices, you need to have the culture of DevOps, which means developers operating their own shit on production. Now, that's a lot of work, and actually not everybody likes that. When I had a monolithic system, back in the days when I was building only monolithic systems, what usually would happen is I had an operation team, that the people who were really good at monitoring the JVM, looking at the systems, keeping them alive, right? Now, with microservices, I have to do this. So I have to learn about observability, about logging, about metrics, about everything else. And, well, I might not be interested into that. Or maybe it just takes a lot of time. So that's going to be your job right now. Next problem is that when you have a company, maybe like 50 people, maybe 100, right? Sooner or later, you'll find out that we are solving the same problems in each microservice. Like we have to have authentication. We need to know who the user is. We have to have some kind of a security, encryption, stuff like that. And then sooner or later, what you're going to get is you're going to get a single team responsible for tools. If you don't have a team for tools, then you might have a guild or a tribe for tooling, right? But either way, somebody's going to spend a lot of time on tooling. So, and these tools were not necessary or needed when we were building a monolithic application. Then you have to think in terms of communication and efficiency, which means that, okay, the overhead of HTTP is quite large, and then latency, and you have to start building the read models, basically, right? And the communication complexity. When you call a method from another method in Java, basically a module from another module, then what happens is either you have an answer or you have an exception, or maybe you have an error and the whole JVM blows up, but that's it. Now it's much more complex because, well, maybe they got the message and I just didn't get the packets that were sent as a response. Or maybe I'll try to retry. How long should I retry? What happens if I try too much? What is the fallback there? And then I need to implement a circuit breaker, maybe, right? So there's a lot of things that can have to go wrong when in communication, and you have to handle them. And if it's not reactive, it's actually suboptimal CPU usage. And I'm not going to the details of that, but just believe me that whenever you see Spring Boot applications on a few thousand or a few hundred servers, and they are not reactive, most likely the CPU is used in 20% at most, okay? What happens is that people do not know how to optimize those applications in terms of actually, we still have a lot of CPU, we still have a lot of memory, and we still have a lot of I/O, but we run out of threads in our thread pools, right? So you have to monitor those thread pools and change the Hikari driver threads, and then change the Tomcat threads, and so on, so on. A lot of work that a lot of people don't do at all. And then you have to pay for more servers, even if you don't use them. That's not a problem with reactive programming, but you have to learn reactive programming, right? And end-to-end tests are not possible anymore. Why? Because you cannot build environment, or basically, test environment, which would be one-to-one with the production environment. How is that so? Well, the problem is that because the deployments of different microservices are independent, you will always have a situation with even 3 microservices, you have 7 different possibilities when you are trying to deploy them to production in terms of which microservices will be there when your service runs. So you'd have to create like 7 different environments there, and you'd have to run your end-to-end tests there. So just don't do it. This is with 3 microservices. The more you have, the more it's impossible, right? So instead of doing all of that, just focus on testing testing each microservice alone using unit and integration tests and acceptance tests, and then testing the contracts using something like consumer-driven contracts, right? Or the libraries for that. But end-to-end tests, not possible. Okay. With that approach, how about the problems of an event-driven system? Event-driven system, this is a distributed system which, well, the whole of the communication is actually asynchronous, right? So what kind of problems do we have there? Well, first of all, you need at least one person, most likely a few, to do a PhD on that message bus that you're going to use. Why? Because that's the blood, the veins of your system, right? This is where the blood flows. So basically, if this goes down, your whole system is down, right? This is the most important part. And those systems are usually not that simple. When you use something advanced like Kafka, there's a lot of reading there, right? So if somebody has got to do a PhD on that, and you can think, okay, I'm going to buy something, like get something managed for me, managed software from Microsoft, AWS, something else, right? Then you have another problem. Maybe there's less documentation. You think it's going to be easier because it's already managed, but then there is less documentation because, first of all, there is less developers using that. And then there's another problem. The marketing people lie a lot, okay? So they are telling you that what kind of qualities it provides, and then you find out that that's not true, right? And what do? You can't do anything with that, right? Okay, so that's the first problem, but there are more problems there. The next problem is that people do not understand the different types of events that are going in event-driven systems. And you can have those events which are public, which means that they are going between different teams, and they are very important because when you have them, what happens is you're never aware how many different consumers are there, how many different microservices and teams consume those events. So you have to go extra length to actually keep that stable, backward compatible, to migrate all the events and stuff like this. But there are different types of events. What if I have like 13 microservices within my single team? Then this type of events which travel through this between those microservices, I don't have to inform anybody when I'm changing the schema there, right? I could do something even atrocious, like, for example, take all those microservices down, update them, and deploy them again. Like within a single team, that's still possible, even though that's an antithesis of the microservices, right? So what happens when you mix those two different types of events? If somebody from another team tries to use my own internal events, right, I will never know when I break them. Okay, that's the problem. So you have to make sure that everybody understands that So this topic, for example, is for public events, and that's my own. Don't touch it, right? Or it's going to break. There is even another kind of events when these are the private events when a single microservice sends those events to itself. Why would it do that? Just because you don't have a database, and you don't need the database when your message bus is persistent, for example. So sometimes that's why we do it, right? And then there is another types of events. We're talking about event storming, for example. Event storming events are not the kind of events that you send here, right, in event-driven system. Then we talk about event sourcing. So events in event sourcing is a pattern of basically persistence. How do we persist those events, or the data, basically, right? These are not the same type of events that travel through different microservices. So they are all called events, but a lot of people actually are making the mistake of thinking that this is the same thing. It is not, actually, right? Event sourcing is about persistence. Event-driven architecture is about communication, and event storming is about analysis, right? That's it. So that can create a lot of chaos. And if you think about it, there are just 3 different ways that actually systems communicate. And I'm talking about both the modules inside a single monolithic application or microservices. When you have 2 different modules or microservices, what you can have is one of the 3. The first one is query. One of the microservices or modules asks another one, hey, give me something, right? Or there is a command, which is an intention, please do something for me, like calculate this cost, okay? And there are events, and events are a stating of a fact which has already happened, right? This is asynchronous by nature, so this is something like car was rented, right? Now, what happens is you can have a system with all 3 of them, but you can also have a system with only queries and commands. You can even have a system with only events. That would be the event-driven system, right? But they have different qualities, and basically they bring with them different responsibilities and different behavior, okay? Now, when you have a query, take a look at this one. Find nearby cars. We talk with one module or maybe a microservice car finder. Then we talk about with other modules. Now, if you think about the query, what happens quite often is it's very inefficient when we cannot do join between tables, right? And we cannot do join between tables because that's the definition of a module. And that's what actually prevents us from going into the spaghetti code and the kind of a big ball of shit type of a system called monolithic non-modular system that everybody has, right? So we got this car finder, and we can say get available cars to car rental, and take all those cars, maybe the 1,000 of them, and then ask locator get car locations, giving it 1,000 IDs, right? So that will be a query with 1,000 IDs, and all we are trying to search here is all the cars which are available at the time, right? That is a very inefficient approach of from the perspective of communicating with the database and from the perspective of how long it's going to take. So queries are all great except when they are not, and here that's going to be a very painful query, and it's going to take a lot of time. So what else can we do? Well, we could have a cache, right? How about having a cache for the locations? The problem is with the cache. There are 2, actually. The first one is you don't know when to invalidate the cache. And the second one, so you usually based it on time, like every 5 seconds, so you got stale data there, and you could have it better. And the second one is you have to actually keep the cache, or you have to have so little information there that you can keep it all in the memory, right? So then you think, okay, what is the other approach? And if this is microservices, it's even worse, because then you are making HTTP calls, right? So it really gets slow. And if you think about it, the optimal number of external calls outside of your microservice when you need to give answer to the user is 0. You should be able to not ask anyone else when you really want to go fast. Like you should maybe search inside your own database on the same machine. That would be the fastest. And that will be the fastest due to speed of light. This is something called data locality, right? Okay, so how can we speed it up? And then you see that you can build read models. So instead of doing queries, you're going to create events. So basically, instead of car finder asking all their microservices about the information, those microservices or modules are going to send that information when it changes. So basically, car rental can say car was rented, car was returned. Locator can say car car has moved. And then you create this in your module. You create a database and tables, and then you put that information there, so it's very easy and fast to access when you have a query from a user, right? Now, this approach is called a read model. You are building a model of what's going on inside different microservices, right? What is the situation about the car and where is it located, right? Now, this read model has got this beautiful property that whenever this is microservices, you are not doing any external calls, but even within a monolithic system, when these are internal calls inside the JVM, it's much faster, because then you can create this read model so that the tables, or basically the data structure inside the database, is exactly the way you would like it to get it fast and push it to the user, right? So this is the same thing we do with CQRS, Command Query Responsibility Segregation, when we approach a rich domain problem, right? But now we are talking about using this between different modules, okay? So data is optimized for query already. And then after the events, you get those comments, right? Now, comments have another problem. Comments are about intentions. So you're saying from one module to another, do something for me, like calculate cost. And here's the problem. Is that am I live? Because I lost you for a moment.
Yeah, it's fine already, but
okay, cool.
There was some issues.
How much did we lost?
Like 50 seconds, something like that.
50 seconds. God damn it. God damn it. We have some problems with the internet connection, I think. Yeah. Okay, let me see if this is on my side. Google.com, ping. 4 milliseconds of a round trip. That sounds okay. So I'm not losing connection. Okay, let's see and let's monitor this. Okay, so let's continue.
And the screen is not shared.
Not shared, so I need to share it again. Okay, cool.
Yeah, would be nice.
Let's see. That's the fallacies of the distributed system, right? Okay, can you see it now?
Yes.
Okay, cool. So I will assume that what you lost is the comments part. So basically, the comments are about the intentions. The sender has got to understand what is the process in the recipient. And the problem is that whenever these two are built by different modules, the different teams, the problem is that information or that knowledge about when the cost is calculated is going to be outdated soon. So it would be much better if the cost calculator team would handle this by itself, and you would not have to understand when should the cost be calculated inside the car rental. So within a single team, those commands are all fine, but between different teams, events are much better, because events are a simple statement of a fact which happened inside a single module. So take a look at this. We are doing exactly the same logic. We are saying the cost calculator is going to calculate the cost. However, when car rental sends an event or basically calls a method of a cost calculator, right, it says car was rented, which means this is what I know because I'm the car rental. This is what I'm responsible for. I'm basing, this event is based on my internal logic and everything that I know, right? So should you calculate the cost? It's up to you. It's your job. If we want to change when the cost is calculated, that's not a problem because we can do it within the cost calculator without touching the car rental, right? This is the important part. I see request timeouts. Can you hear me?
Yes, we can hear you.
Yeah, so that's an interesting network we have right now. No route to cost and request timeouts. Okay, let's continue. Let's see if it goes. Anyway. Events are much safer than actually any kind of commands, basically, right? Or even queries. And the reason for it is very simple, because when we have it, we can reason only about that single thing that we have. and I see that we have a wrong video. That's the feed I wanted. Okay, cool. Anyway, so events are safer. You can base your read models on them, but the important thing is the local reason, right? Now, when you want to have your system all based on events, that's all great, but it's actually going to take a little bit more time because you have to create those read models, right? You have to implement them. And then there's another problem with events. Yeah, when you have something like a persistent event storage, or basically an event bus, transaction log, something like that, distributed transaction log, the problem is from time to time you will have to do a baseline, and nobody talks about it, right? So what's a baseline? Basically, what happens is that you have this situation when you are sending events from one microservice to another microservice, let's say, right? And that other microservice should be able to like move back in time and basically read the events from the beginning of the time when they say that, oh, we need to recalculate this because we had like an error, right? But that works only if those events that you've sent on the wire or basically to the event bus are already all right and okay. What happens if we had an error when we were sending those events? So basically inside the car rental module, right, or microservice. Now, what that means is that all the events that we had so far are wrong, right? They do not have necessary data, or maybe the data is wrong there. So what can we do with that? Sooner or later, you will find out that quite often what you will want to do is actually create a baseline, which is, oh, you know what? Let's send all the events let's generate all the events from car rental again, so that we can clean up the information on the topic, or basically send the proper information on the topic so that other cost calculators can calculate their stuff, right? And that's okay, you can do that. The problem is you need to clear the databases then in the consumers. So that's a lot of work, and a lot of like, those consumers are most likely idempotent, because otherwise you would have to have guarantees about how often do you get like exactly once delivery, or at most one delivery. And usually what we have is at least one delivery. So what happens is that this baseline is a problematic thing, and it creates a lot of hassle and a lot of work for different teams. Nobody talks about it. That's the daily job of the teams that are actually doing work in an event-driven system, right? Okay, and then we have to talk about something else, which a lot of experienced architects have a problem with. Like 20 or 30 years ago, that would be something very important, but it's not anymore. When you have a system about renting cars, the first thing that people do is they create a module for cars, okay? Now, if you create a module and it's called car module, then what is the responsibility for that module, right? This sounds like a responsibility for a noun, not for a process. And then when you start actually putting all the methods and basically like all the calls there, you will find out that it's responsible for everything. Renting a car, returning a car, moving the car, or where the car actually moved, it stores that information as well, parking and so on and so on. And that makes no sense, because that module grows and is quite big sooner or later, and turns itself into a monolith of its own without any modules inside of it, right? And your whole architecture is down, right? It's too big. So this part of the way we used to develop was actually with this data ownership concept, that a single module owns the data about the car. That's not true anymore. This is bullshit, okay? This used to be true. Well, actually, it wasn't true even 30 years ago. It's just how we thought about systems, because the database guys, the Oracle, for example, were pushing too much on, the data is the most important part of the system, right? Now, what we should do instead is we should model our modules around processes, not about data. So how would that system look like? This part of the system would look like this. We would have a module for renting cars. We would have a module for returning cars. We would have something for calculating the cost. We would have something for locating the nearest car, and so on and so on. And there is not a single car module inside this system, because it's not necessary. Our system is all about processes around renting cars, around cars. It's not about the car itself, okay? And then each of those modules can have a single responsibility for a process, and they are much easier to build, they are much smaller, and much easier to think about, okay? So nobody owns the car. Nobody owns those events. Those events, the data that happens, or basically that is being produced, that goes into the message bus, things like car was rented, you can replicate them safely because, well, these are just statements of facts, and you don't discuss with facts. Like the third normal form and the fifth normal form, all of this was invented to prohibit the situation when part of the system would be modified and the rest of the system would have stale data, right? But that's not true anymore for us. Because if this is a monolithic system, then you get transaction over all those modules. And because each module has got its own database and nobody else is pushing data from the outside, then it means that all the data is stable all the time. Okay. Now, if these are microservices, I'm very sorry, but you can only have eventual consistency due to the speed of light limit, which means you will never get the information up to date on all the microservices, and you don't have to, because those events that happened, they are basically a statement of a fact in time. They happened there at a specific timestamp. So you don't have to think about changing them. Events are not being changed there, right? So these are the single point of truths. And when you have a single point of truth, then you have another problem, which are the invariants. Take a look at the design on the right side. If we want to provide an invariant, which is something that is always true, right? For example, the rule that we have, we can only rent a car that is not already rented. What happens then? In that situation, when the user calls rent a car, okay, then you have to verify that this car is not already rented. And you can easily do this because you have a database inside car rental, and you can do just an optimistic log or maybe pessimistic log, and you can basically log this operation on the database so that even if you have several users trying to rent the same car, only one of them gets it, right? Easy as that. Now, but if you have car return, what happens that if you have another module, or even better, if you have another microservice, because single point of truth is usually about microservices, then the problem is that we cannot actually make that decision. Like if we had another rule about we cannot return a car which is not rented yet, then we have a problem, right? Because if you have this car return would need to know about the rented cars, and then it would need to inform the car rental about the returned cars, which would create a kind of a cycle there, right? So we have to think in terms, okay, maybe we will skip that rule and basically do not have that invariant so that you can return a car which was not rented, but it's just that the other services like a rental are going to ignore this, right? So we have the important part about the single point of truth is this. There should be only a single microservice which states a given fact, okay? For each event, there is only one source of that event. And then you can protect about the changes or the rules inside the module by using a database and basically using logs on the database, even in a multi-threaded environment, which is everything we have, right? So that is easy. The problem is when you have invariants which are spread across many different data with from different modules. Then you have to find another way to do it, okay? And then another problem is, like, if we want to see that data, remember, we cannot make a query on all those databases of different services. So what we want to do when we want to show, like, what are the cars and are they moving right now? Are they returned or rented or are they available, right? Then you create another microservice, which is a dashboard or another module. And you get that information there and you store it there so it can be returned very, very fast. So this is like, and again, the query part from the CQRS pattern, right? Okay, next problem. Orchestration and choreography, okay? The problem is that in a system where you have a monolithic system, basically, when you have modules, orchestration is when a single module tells everyone else what to do, right? So here's an example. You got the car rental, and the car rental says, calculate cost, prepare invoice, calculate parking time, right? Now, if all those microservices are built by a single team, that would be okay. But when we have several teams, again, the same situation as with commands, because these are actually commands, that team responsible for car rental will not be up to date after half a year about, well, how we do calculate parking time and when should we do it. So it breaks really, really fast in a distributed system, especially, right? So when you are building a system with several teams, it's much safer to not use orchestration, but instead to use choreography, which means that we are only going to react on different events. There is not a central point that tells you what you should do, but instead that microservice car rental is sending information about what happened at car rental, and then you can make a decision about what should we do then. The cost calculator says, okay, now car was rented, I'm going to start calculating the cost, for example, right? And the dashboard is going to get that information and present it, and the available car finder, and so on and so on, okay? So choreography is much better in distributed systems, and especially in systems built by several teams, to the point where the orchestration is actually an anti-pattern sooner or later, because your people will not have the same knowledge about what happens at other microservices, because you cannot stay up to date with all the processes around it, right? Those systems are usually way too large. Okay, so then you got choreography, and there's another problem with Saga, but I'm not going to skip it for now. Now, the next problem is how small should those modules or microservices be? And I'm going to focus on modules, because with microservices, the problem is kind of a technical. Like, you don't want to have too many microservices there if you're not very good at keeping hundreds and thousands of them alive, perhaps, right? So there is a lot of technical reasoning why you should put several modules inside a single microservice. But right now, let's see how many microservices can we have, okay? Here you have an example. Whenever the developer wants to, like, the requirements are that we are going to, for example, create an invoice and send that invoice to the user at the end of the day, right? What the developer actually does is draws this like okay, this is going to be my module for invoice creating. We are going to ask for the cost of the day, and then we're going to send it over through SMTP or something like that to the user, right? Simple as that. That's not true. If you look inside the invoice creator, what happens is you will find that there's actually a lot of different things going on. And this process is starts with actually learning about, like, if you want to implement this, one person has got to learn about what are the invoices from the law perspective, from a tax perspective, right? What are the rules about invoices? How the billing works, right? So you have to get all that information about, you know, the taxes and so on into your head. But the rest of the process is actually creating a file, so basically a PDF. And you may think this is simple, but I will dare you to actually change your mind, because creating of the PDF so that it looks good, well, you have to learn the API of the library that you use, right? And it's going to take you some time. And then you're going to try and fail at actually making it look well. And take a look at this. These two different steps of the same process, creating and sending an invoice, right? Or maybe even 3 different steps, because we still have to send it through SMTP, and that might be a little bit convoluted as well. Those 3 different steps require a different area of knowledge. So what happens is that you could have 3 developers doing this in parallel, and each one of them would read other types of documents, basically, right? So each developer would get different data into their head to actually be able to implement this. So if we can do that, then it's a benefit for everyone. Let's split that single invoice creator into 3 different modules. Why? Because first of all, if we can implement it in parallel, but also because whenever you are implementing any part of it, even if you are the only person doing this and you do it alone, right, you will have less to think about. Now you have to learn the taxes, you calculate the taxes, this is all fine. You forget about all the taxes, next week you're going to do the PDF, right? And next week you're going to learn how to use Spring integration to send emails, for example. So stuff like this. So how small should those modules be? As small so that you don't have to, like, you should split them as small as possible, but not when after splitting the 2 people that would have this module, these 2 different modules to implement, would need to read the same documentation, basically, right? So it makes sense to split it into different modules so that you have less in your head when you are implementing this. That's it. And that's the heuristic I would use right now. Okay. Now, small modules are easier to replace, refactor, debug. Basically, this is the Unix philosophy. So it really helps. Okay. And then we have another problem, and this problem is about microservices. Now, we might have different users in our microservice, different use cases in our system, and basically different quality requirements. So take a look at this example from like a month ago from Poland, when what we had is this situation when there was a patient, there was a nurse, right? And the patient, they opened, like last month, they opened the registration for the vaccination for people born after 1981, which is me, by the way. So actually, I was born on the 1981. So when that happened, all the patients, all the people born after 1981 were trying to register for vaccination, and they created a distributed denial of service attack on the patient registrator. Now, usually that wouldn't be a problem, right? Because, okay, we don't have to provide a high SLA for that, but we might have a very large traffic. Well, the system can hang for a moment, but who cares, right? The problem was, on the other side of the same system, there was a nurse, and there are people who were actually injecting people with vaccines, right? So doing the vaccination. And they were using exactly the same system. And these people, there's just a number of them, so you got a fixed number of requests per second, but they require a very high SLA. Why? Well, because otherwise the vaccines are going to be thrown away, and basically people came over, like we really tried to speed up this process. And when that was just a single system handling both of those codes. And what happens then, when patients killed the system due to the denial of service attack, the nurses couldn't do an injection, right? So how should that be actually implemented? Well, first of all, what should happen is you should think about when you have a different quality requirements, like the patients require a low SLA, but there might be a high spike in traffic. And the nurses, well, they have fixed APSs because, well, you know how many there are, you can calculate this, but they require a very high SLA. So now what we should do is we should split this application into at least two of them, when one of them handles the patient registration and then sends that information to patient injector, so that when this breaks, the patient registrator breaks, it doesn't impact the other users or the nurses, right? Simple as that. So this is the thing I've learned the hard way. When you have different quality attributes, split the application to smaller parts or different applications so that you can provide them easier, okay? And that's not the only thing. The other thing is that also when we are talking about the SLA, or basically availability, right? In a monolithic application, what happens is that you only have one SLA. Why? Because if your system breaks due to memory leak, the whole system dies, right? Now, in a distributed system, that's not true anymore. You can think about an SLA per process. So basically, what kind of SLA you need to provide. And then you can minimize the failure impact, just as I saw. But you have to think right now about another problem. Well, in IT, what we usually do is we think about, okay, this microservice has got to have high SLA, so I'm going to provide redundancy. Basically, I'm going to create hundreds of them, right? So they do not die. Now, that's one approach. The other approach comes from aviation. And that approach is different. What they say is, okay, since engines are so crucial for flying, let's have as little of them as possible. Why? Because then there is just so many things that can break. And let's make them stable as possible. So you actually prefer to have less engines in an airplane than more engines. And there's also the cost of flying anyway, so the fuel costs and so on, right? So their approach is actually to minimize the number of moving parts, right? And then make them so they work very, very well. That doesn't always happen, as we know from the last 2 years, right, with Boeing. But the important thing here is that maybe we should try this approach, right? Something that is stable doesn't break. But that's true only if the requirements for the engines do not change, and we do not try to implement new features there. And this is a very interesting research from Microsoft. Basically, Microsoft has got a lot of interesting research there about what we should learn, how we can actually assume how many errors are we going to make based on the distribution of the organization and basically the the structure of the teams that are creating this. And what they found out between all the different things they found out one very interesting, which is that if you have something that changes a lot, then what it means is going to be very, very hard if you have a lot of new features to keep it stable. So basically, we are trying to never have a microservice or an application when you have to provide high SLA and it's got a high frequency of changes. Don't do that. This is going to be horribly difficult to do. However, when you have low SLA, then the high change of frequency of changes is not very problematic, right? And the other way around. If things do not change a lot in that microservice, then you can provide a high SLA because, well, sooner or later, you're going to fix all the bugs. And this piece of software will actually become stable, okay? Even the shitty monolithic applications that we had could become stable if there are no changes inside of them. Now, so try to split your microservices and basically your system into parts where you have either high SLA and low change of frequency or the other way around, but never do high SLA and a high change of frequency. These parts of the system are going to be very difficult to build, okay? Okay. So now let's move to the eventual consistency. So you have to understand that actually, last 20 years, I have built one system using distributed transaction, okay? And it was unnecessary. It was an overkill. Like the world doesn't work on distributed transactions. And there are several reasons for that, right? One of them is that the cost of a distributed transaction is huge in terms of actually the performance, right? You can learn about it reading the white paper Life Beyond Distributed Transactions from Pat Hunt from Amazon, and then you can take a look at about the kind of guarantees that we can have inside a system, right? Now, if you think that you can provide exactly one's guarantees, that's going to be also impacting the performance of the system. So you usually don't need that, and usually don't want that. So we need most likely at least one delivery guarantees. And the things that I wish I knew when I started developing this kind of system is that it's actually very easy to do, okay? Now, you may think that you need kind of like Apache Kafka, persistent storage, and so on to do this kind of things when sooner or later there'll be that message will go into to another microservice, basically. But that's not true, because what you can do is you can use something called an outbox button. If I have a service and I need to send information to other services, I can start a transaction, save it into 3 different tables, okay, and commit the transaction. Then I can have another thread, which would have annotation scheduled in Spring, so basically something that runs from time to time, that will search for that information in one of the extra tables, try to send it to the client, and when it succeeds, then it will delete that information and commit. But if it fails, then it will try again when it's scheduled the next time, right? So with only those 2 things, you can provide eventual consistency, because sooner or later, the client will actually receive that message. Now, most likely, you need another thread or another scheduled method, which will look for timeouts, because you might have messages that will never be received because, for example, their structure is wrong, or the serialization, for example, is wrong, right? So after some time, it's good to actually get rid of that message and just log error, right? But it sounds so easy when you have a transactional database to do it that you don't have to thinking, well, how am I going to prove when we have a REST communication that there is eventual consistency? It's really easy to do, okay? Even if you do not have a transactional database, it's very simple, because you can model this as a domain state. So basically, you will do something like this. When you would update using a database with only atomic operations, but no transactions, you can split it into different steps of the same process, and then you can do the same exact thing, which is another scheduled method. So basically, a scheduler there that will fire up a process when you are trying to push all the information which is hanging there. So basically, if you have any like here articles trying to be sent to another microservice for several seconds, then it will try to do it again, and after a few minutes, it will most likely stop. So this is really easy to do, okay? Don't be afraid of eventual consistency, okay? And at the last, I would like to recommend the books I wish I had read when I was starting architecture, my experience as an architect, but they were not available, most of them back then. Actually, none of them were available back then. So first of all, I would recommend Software Architecture for Developers by Simon Brown. That's a very basic book, but it's a very good book to level up all your knowledge. Even if you are an architect with a lot of experience, you might find something new there, right? And you'll be thankful that you found it. Then another good book is the book that actually came out last year, which is Fundamentals of Software Architecture and Engineering Approach by Mark Richards and Neil Ford. And the great thing is, if you are in Poland, translated, this book costs like nothing, 50 zloty, right? So it's very, very cheap in Poland. In English, it's a little bit more expensive, just like all the IT books, okay? Another one is Designing Event-Driven Systems by Ben Stopford, which is about the event-driven systems, as the name suggests. And then Domain-Driven Design, which is Tackling Complexity in the Heart of Software by Eric Evans, which is the basically for the domain-driven design. Very good book, even these days. And if you want to go into reactive system, then I would suggest Reactive Design Patterns by Roland Kohn. But the thing here is, this is not the kind of a book that will teach you how to do reactive programming. It's about the patterns. So it explains what kind of problems you're trying to approach with reactive design and how you can build those systems using different approaches like actor-based architecture or maybe something else, right? If you want to just learn reactive programming, the documentation for Project Reactor and for Eric's Java is much better. Not maybe much better, but much more detailed. So you won't learn from that. Okay, so these are all the things that I wish I knew when I started developing the systems as an architect. And as I said, I started on the third year of the university, actually. They gave me actually in the third or fourth year of the university, they gave me a large system to design. I did everything wrong in there. And for several years, I was doing a lot of wrong things. And I still do, like I'm not a very smart person, but I'm learning from my mistakes, and please learn from mine so you don't have to make those same mistakes again. Thank you. Questions?
Kuba, we have two questions. One on Q&A section.
Sure, let me have a look at it.
And the second is on facts.
Q&A, let's start with the Q&A. Okay, no questions. I don't see any questions on the Q&A.
There is one open from Pavel. Okay.
Okay, can you read it? Because I can see it, yeah.
How to choose the best type of architecture for project? Are there one or two advantages of each architecture that can help with the decision?
Yeah. So I was just today I was talking about this during the workshop, because I give workshops on architecture, and you have to think in terms, okay, this is a bigger problem, but it's a solved problem, right? So instead of giving you, like, you have to learn how to think in terms, and you have to compare those things. Okay, now I see the question. You have to compare those things. So like, what I do on the workshops is actually build the same system with 3 different types of architecture so that you can learn whether you want a modular monolith or not. But the simple heuristics would be something like this. If you have a single team, you can build a monolithic system, right? There are many advantages of building a modular monolithic system, okay? But the question is, can you even do it? With a single team, you can. When you have 50 people, you can't. Just don't try, right? In theory, you could, but it's going to turn into a big ball of mud anyway, right? So don't do it. Now, the next question is, what happens if you have like a deployment and something breaks? If your business allows you, like you can handle the big risk of deployment, then you can build a monolithic system. But if the business cannot, because people will die, don't do monolithic systems, right? You have to go into distributed systems there. The next thing is about what kind of tools do you have already on you? So basically, what is already provided by other teams? If I have Kafka, Kubernetes, somebody keeping an eye on the databases, and basically all of this is already provided, then I have a very good environment to do microservices, right? So it's easy for me. Now, if I had to do all of it myself and create all those, set up the Kubernetes cluster on-premise, for example, I would give up. I would say, no, that's way too much work. for a single team to handle this. So these are the kind of analysis. And between the distributed synchronous systems and event-based systems, I think the most important part is it's better to communicate between teams when using events, because then you do not depend on each other so much, and there is no temporal coupling. But within a single team, it's all up, and you should decide based on other things. Like, for example, how much energy are you going to actually burn when you do this as a synchronous system? And how much would you burn when you do this as an asynchronous system? And I can show you, maybe not today because I'm tired, but I have several examples of different systems or different parts of systems where for this part, it would be much better to do it in a synchronous way. It's going to be cheaper in terms of the amount of coal burned in this country, right? And other parts of the system where it's going to be much cheaper about when we send this as events. Why? Because you have to look at the amount of communication that you do. Okay, so I hope that helped a little bit. Okay, so what else do we have?
Second question is on chat. Oh, quite long.
That's a large one. Yeah. Let me read this. From what I see, majority of the systems are written like microservices per noun. Yeah, that's true. As in my opinion, module services per verb force you to use CQRS. And the problem is that people don't know how to do it. And it's hard to convince them to do stuff in a different way, especially when the per noun architecture is understandable for everyone. And in the beginning, allows to deliver stuff really quick, as there is much less modules. And what's most important, you don't have production experience with the right approach. You've only heard about it on some conferences or at Java user group, like right now, right? Any tips how to encourage people to try per verb, or as I say, per process approach, except hiring some external consultants who could do it? Well, you just took it from my hands. I was just about to actually recommend my own services so we can hire me, I can earn a lot of money, and I'll explain how to do it. Well, maybe just try and maybe do something different. How about design this first? Like the worst thing that happens is that people design and implement it right away, right? So they would see like, okay, we are going to, we know how to do microservices per noun. So basically not the single point of truth, but instead the data ownership, which has got a lot of disadvantages, so it makes no sense. So let's just implement this. That's what people do. And what I would suggest, let's not implement this. Let's design this first, and then let's design the same thing, but this time using an approach where each microservice is responsible for a process, okay, or each module, and compare those two. And when you compare them, and remember, the bigger the microservice or the bigger the module, the harder it is to actually write it, right? The harder it is to maintain it, right? And what you will find out sooner or later is that when you do this with the noun, with the verbs, with the processes, those microservices are smaller. It's easier to reason about the system. So try showing that, basically, right? Just, you know, we are building a large system. This is going to be a system that works for the next 10 years, most likely. This is a live architecture there. So it makes a lot of sense to spend another day creating this system as another class of a system, right? Designing this and comparing the different designs. And I never see that, right? People are like, okay, the first design that comes to my mind is the one we are doing. Thank you very much. Bye-bye, right? That's the wrong approach. Let's spend some time on this. Like, we don't have to have like a month designing this thing. One day, God damn it, spend 2 hours trying to design this with a different approach. And that's it. That's what I would suggest. What else do we have? What do you think about the concept of starting with modular monolith and then splitting into microservices if needed? In most greenfield project, requirements change so often that it's hard to strictly define boundaries. Okay, these are two different problems. So first of all, if you want to start with a modular monolith and then go into microservices, it's completely fine. I would always do that when I don't have the infrastructure yet. However, if I already have the infrastructure, if I have Kubernetes, if I have the message bus, all that stuff around and monitoring, right? Then I don't need to start with the monolithic application anymore, because like for me, there's not much difference whether I have 5 or 6 microservices. There's not much difference whether I have 13 or 14 microservices. Okay, I can handle them now. So that's one question. Now the other one is, In most greenfield projects, requirements change so fast that it's hard to strictly define boundaries. That is correct. That is true. But that's not the problem of microservices itself. It's the problem about the architecture. And the microservices can actually help you with that. Because what happens? Well, the requirements change. So what should we do? I'll give you an example. What I did is I just deleted the whole module. That's it. Deleted the whole repository of a microservice. With modular approach and with microservices, the good thing is you can replace those things easily. And with event-driven approach, when you don't have direct calls, what happens is you can just delete a single microservice when it's no longer necessary or when the logic changes. So I'm not sure whether this is actually a better approach when you have a lot of changes in the requirements. I always have a lot of changes in requirements. I would go into microservices anyway if I had that infrastructure set up. Okay. Then there's another question. There is a problem to learn to think asynchronous. That's correct. We pretend to be asynchronous, but try to be synchronous. How to train the team to think and design asynchronous? Use the book. Basically, the book, Event-Driven Systems, is very good at this, right? The rest is just experience. And how do you get experience? You get it on project, or you do it. You learn it on the workshop, right? These are the way to do it. Remember that the way we learn is actually by making mistakes. So if you make a lot of mistakes, you sooner or later will learn. And it's much better to learn those mistakes either by reading books and learning from somebody else's mistakes, or by doing workshops so that you can develop your own skill instead of doing this in production. Okay. No more questions, I guess.
Yes. So, Jakub, thank you very much for your presentation.
Thank you.
Last thing, you can choose one question, the best question in your opinion, and we can send a JetBrains license for such colleague.
Okay. So in that case, I'm going to choose the longest question because I'm not sure which one is the best, but I know that Maciej has got a real problem there because he wrote like a whole chapter on this. So it's important for him. So I think he needs some help, and I would love him to have the license.
Okay. So Maciej, please contact with me via Meetup, via Facebook, whatever way, and I will send you a code. So that's all. I will paste once more a link to the Gutter Town. So I'd like to invite all of you to take part in the after party, discuss, maybe have some other questions. Yeah, so that's all. Once more, Jakub, thank you very much. And
thank you very much.
We'll see you next time in person.
Yeah, hopefully. Bye-bye.
Yep, bye.